Hello, everyone, and thanks for joining us today. My name is Chris Castillo, Marketing Communications Specialist for HR Green, and I'd like to welcome you all to today's webinar, 5G Small Cell Basics, Surfing the Small Cell Tsunami. Today's webinar is being brought to you by HR Green. In the next hour, you'll learn how your local government can negotiate win-win outcomes that benefit carriers while addressing key community concerns such as aesthetics and public safety. Before I turn it over to our panelists and jump into the content, let me first provide you with some direction on how to use GoToWebinar. Let's look at GoToWebinar options for a moment. You can show or hide your control panel at the top of the toolbox with the red arrow. You can put your screen in full screen mode using the rectangle in the upper right of the toolbox. Attendees are muted during the webinar, but you can ask a question using your toolbox. To do so, click on the plus sign next to questions and type your question. Once you've typed it, click send. We'll be taking your questions at the end of the presentation, so feel free to send them in at any time. I'll be your moderator today, and would like to introduce our presenters for today. Bart Miller is an attorney. He's got 30+ years at a Colorado office of Legislative Legal Services, which was the in-house legal counsel for the Colorado General Assembly. He's currently a Colorado local government attorney for Collins, Cockrell, and Cole. George Wentz has over 40 years of municipal service management, including Colorado and in California. He's a former city manager and currently deputy city manager in Jurupa Valley, California. His current role is a vice president of governmental services at HR Green. Dave Zelnock has been a public works director for over 20 years at various Colorado cities. He's helped install hundreds of miles of municipal fiber infrastructure in Colorado. He helped pioneer Colorado's second major city exemption from SB 152 and is currently a local government services manager for HR Green. A little bit about HR Green. We're a multidisciplinary professional services and construction firm offering planning, technical consulting, including 5G small cell deployment, broadband and fiber, engineering, environmental services, and construction to clients in diverse markets. Founded in 1913, HR Green is one of America's oldest design and construction firms, and we enjoy a long-standing reputation for building communities and improving lives. The firm now employs over 450 people in 8 states and has helped many agencies nationwide in broad-based municipal engineering. Our business lines provide comprehensive services in transportation, water, governmental services, land development, environmental, and construction. Here's today's agenda. Part 1, we'll talk about federal and state laws presented by Attorney Bart Miller. And in Part 2, Dave Zelnock will provide an overview about this technology, followed by George Wentz, who will present Part 3, providing advice on next steps and things that local governments can do to maintain authority and flexibility for small cell rollouts. At the end, I'll share any questions that our audience has asked and provide our presenters a chance to answer your questions. After the session, you all get an email that'll contain a link to a recording of the video of the webinar as well for your reference. I'd like to now turn it over to Bart Miller, who will be taking over Part 1, Federal and State Law. Bart?
Thank you, Christopher. I'm very glad that all of you are able to participate in our webinar today. Welcome. As many of you may know, there is a labyrinth of federal and state laws that affect telecommunications, particularly mobile telephone service. As U.S. mobile telephone service begins to move toward the 5G era, the way these federal and state laws work together will have an effect on the speed and efficiency with which we move toward and into 5G. In this webinar, we will be focusing on how these federal and state laws affect the construction of the physical infrastructure necessary for next generation of mobile telephone service. Our presenters following me will talk in more detail about the significant differences between small cell infrastructure necessary for 5G and the macro cell infrastructure with which you may already be familiar. In September of this year, the Federal Communications Commission, the FCC, adopted a declaratory ruling, report, and order that enacted preemptions of local authority over small cell wireless facility deployment and management of local rights-of-way in particular. This FCC action took effect on January 14, 2019, so it's already in effect now. But as we will discuss in a few minutes, there is a federal court challenge to the FCC's action that may ultimately affect this FCC decision. Now, the new FCC rules, what do? They create a shot clock, which shortens the time cities and local governments must process applications for small cells. The limits in the FCC rules are 60 days for co-location on pre-existing structures and 90 days for new builds. The FCC rule also codifies an existing 90 and 150-day shot clock that was put in effect for non-small cell wireless facility deployments that were actually established in a similar 2009 FCC declaratory ruling. The FCC regulations also limit application fees for small cells, as well as recurring fees. They prohibit cities from assessing fees that include anything other than a reasonable approximation of reasonable costs for processing these types of land use applications. The regulations prohibit local governments from enforcing aesthetic guidelines for small cell facilities if those guidelines are not in writing by April 15, 2019. So that deadline, of course, has already passed. There is disagreement in the legal community over whether the April 15 deadline is a hard deadline, making it so that if a local government does not have aesthetic guidelines in effect by that date, the local government cannot adopt guidelines later, or a soft deadline, making it so that these types of guidelines must be in writing beginning April 15, or they may not be enforced. I tend to believe the April 15 deadline is a soft deadline and advise clients to get aesthetic guidelines adopted and in writing with all deliberate speed, as soon as you can, if they have not already been put in place. In short, the new FCC rules severely limit the aesthetic review and other requirements that can be imposed on the siting of these types of facilities. The idea of the new FCC rules is that if a local government limits mobile infrastructure deployment more stringently than the FCC rules will preempt local authority and allow a telecommunications provider to move forward despite the more stringent local rules. The FCC is doing this under its authority to interpret provisions of federal telecommunications law that bar a local government from taking actions that have the effect of denying telecommunications services to a local area. Now, there has been a federal court lawsuit, actually many lawsuits, filed by numerous local governments in many parts of the country challenging the FCC's shot clock rulemaking. This is kind of a long story, but this case is now named Sprint Corporation versus the FCC. It is case number 19-70123 in the 9th U.S. Circuit Court of Appeals on the West Coast. I'm giving you the case number in the event you want to try to follow the case, if you're kind of a legal nerd like me. This case was originally called the City of San Jose et al. Versus the FCC. It was actually originally filed in the 9th U.S. Circuit Court of Appeals, but because numerous municipalities from across the country brought similar suits, the case was consolidated at first in the 10th U.S. Circuit Court of Appeals, which is based where I am in Denver, Colorado. The federal courts have a multi-jurisdictional panel lottery system that sorts out how to consolidate a challenge like this brought in multiple places across the country. In this situation, that panel decided the case should be consolidated in the 10th U.S. Circuit Court of Appeals. The 10th Circuit does have a reputation for being more conservative than the 9th Circuit and one of the more conservative circuits in the country. However, for whatever reason, the 10th U.S. Circuit Court of Appeals decided to retransfer the case back to the 9th Circuit Court of Appeals, so it's now back there. Prior to transferring the case back to the 9th Circuit, the 10th U.S. Circuit Court of Appeals denied a request for an injunction preventing the FCC rules from taking effect on schedule this past January. So the FCC rules are currently in effect. This case seeks to invalidate the FCC's action to impose the new shot clocks for small cell development. The court could invalidate the FCC rules. It's hard to predict if the challengers of the FCC action will ultimately be successful. The FCC decision appears to be well-reasoned and builds on the FCC's 2009 declaratory order imposing shot clocks for macro cell development. This legal challenge is currently in the preliminary stages. In fact, the parties attended a case conference just this past week on April 18th, 2019, and the appellate commissioner who's in charge of the procedural issues with the case approved a briefing schedule for the case. The briefing schedule calls for the case to be fully briefed in the fall with the possibility of a hearing sometime thereafter. We'll have to see what happens with this case as it moves forward. It has the potential of changing the FCC rules or not, depending on whether the appellate court sides with the petitioners or the FCC. In addition to the FCC ruling on small cell development, the states depicted on this slide that you're looking at now have also passed their own legislation on small cell development. As you can see, these states include Colorado, Illinois, Florida, and Texas, to name just several, a significant number, and a significant complication in addition to the FCC order that's currently under federal court review. An example of why this is important is the slide you're looking at now. This is an example of what has happened in Houston, Texas. These are this is a depiction of actual small cell applications by just 4 wireless entities. In a 10-block area, 20 towers are being sited. This is just one city's experience. Now, an example of just one of these state laws that I was referring to a minute ago is what has occurred here in Colorado, where I'm based. Colorado has enacted its own small cell law. This was our Colorado House Bill 17-1193 that went into effect on July 1, 2017. This law provides that it is applicable to any political subdivision or local government entity in Colorado. The law's deadlines, however, are somewhat different than the new FCC shot clock rules. A Colorado local government has to process a complete small cell application within 90 days versus 60 days per the FCC rule for co-location, replacement, or modification of a small cell facility, and within 150 days if the application involves the location of a new structure or new wireless facility. Under our Colorado law, a provider has the right to locate or co-locate small cell facilities in the rights-of-way owned by the local government. Local governments cannot request or receive from a provider in exchange for or as a condition to attach devices to poles any in-kind payment, and the law severely limits the ability of local governments to charge other than the actual cost of processing a land use application. So no ongoing rental of facilities and that type of thing for areas that are in the public right-of-way. A big takeaway here is that you need to determine what your state is doing with respect to small cell development. Has your state enacted its own laws, imposing deadlines on local governments with land use power, or is your state relying on the FCC shot clock rules? A final big legal takeaway: it is very likely that the federal government in many states will limit the ability of local governments to impose traditional land use regulations on the development of small cell infrastructure moving forward. Now, at this point, I'm going to turn it over to Dave, who is going to tell you more about this particular type of technology.
Bart, thank you so much. Wow, it was a great rundown, and I appreciate the fresh information. Since the last time we did one of these, I think we've got over 100 people now on and registered. So thank you all for joining us this morning or this afternoon, depending where you're at. A few quick words about what is this technology. As you're aware, the demand for broadband is growing like a weed. 25% is some of the conservative estimates. I've seen actually 43%. In terms of the amount of demand for broadband. No surprises there. We've all gone from the television sets to HD TV to 4K, soon to be 8K. Really, though, what's driving most of this, though, is upgrades in cell phones. Nobody even has a flip phone hardly anymore, a 2G or 3G phone. LTE is really just a fancy, it's 4G on steroids, really is long-term evolutionary is what LTE stands for. It's just 4G. And frankly, right now, nobody has a 5G phone. I think that there is one carrier starting to provide very limited 5G service in downtown Chicago, soon to be Minneapolis. But really, so much of this work now is positioning by the four major cell phone companies: Verizon, AT&T, T-Mobile, and Sprint are the four big ones out there that are really driving a lot of this forward to us. So, with that. I'd like to just talk about what are small cells really, and show a few example illustrations about what's a small cell and kind of define that. You know, so there are macro cells, which are the big towers that we're all familiar with. Small cells really can be placed on buildings. We're seeing a lot of them really on streetlights, and we'll come back to that, talking about the advantages to that. But they're really being quickly to improve. Really, it's the quality, resilience, and a word that is kind of geekish called latency. So while we're talking about speed, you know, a typical cell phone right now can deliver, maybe if you're on an LTE network, 20 megabits, 30 megabits per second. The goal here with the 5G service is to go from 20 or 30 to over 1,000, and then maybe to 20,000 bits per second. So that's kind of what's going on here. Some more examples of what are small cells. I think are just worth looking at. Some good examples of small cells. Here, there are 2 or 3 of them from the Denver, Colorado area where I'm based. Look at those on the next slide. There we go, thank you. So on the left there, you can see a small cell integrated into a streetlight pole, and we'll talk more about streetlights here in just a moment. If you look closely, there's a vertical cigar tube looking thing that's between the 2 streetlights. So that's actually in downtown Denver, Colorado, where there's no streetlight hanging on it. It's just a tube sticking out of the ground as an owner-operated small cell pole. And then on the right is the traffic signal pole. We've actually done a couple of these in and around the Denver metro area, where our folks have consolidated and put up a new, had the provider put up at their expense a new traffic signal mast, and then integrate within that mast their small cell at their expense. So that saved us, saves typically $50,000 to $100,000 per traffic signal quadrant. You can have 4 of those on a typical pole. The next slide, there you go. The next slide we'll see it's kind of a close-up. One word that you'll hear a lot in the lexicon, as it's called, or the vernacular as it relates to small cells, are Franken-poles, much like Frankenstein. On the left there is what's commonly called a Franken-pole, and kind of a close-up. Those are small cells, which actually a small cell is even defined. State laws define it a little bit differently. Here in Colorado, it's roughly the size, I like to say, of a small bar-size refrigerator. So if you've seen the under-the-cabinet bar-size refrigerators, about that number of cubic feet, 2 to 3 cubic feet, is a commonly held definition of a small cell. Just physically refers to the size of the cell. The next slide here, you'll see also talks a little bit about, okay, so those are small cells. What's 5G? As I mentioned, 5G will take your cell phone from about 20 megabits to 1,000, then eventually up to 20,000 megabits per second. I think, though, even more importantly than the speed coming through your cell phone, though, is what's called the latency. And so if you have a smart car, for example, or a smart city application, the amount of bits you can push through per second, so a gigabit or 20 gigabits is important, but arguably if you're driving a smart car that's interconnected with a larger network, the real important part there is not so much how many bits can you dump in per second, it's how quickly can you get those bits, how little lag is there in the service, and that lag is often called latency. And so they're trying to drive down the latency is arguably more important than even the speed. If you're driving a smart car, you need to know where your car is and all the other cars around you within inches, within milliseconds. And the only way to do that really is not through the existing cell phone network. It's through a virtually zero latency fiber optic based cell phone. So unlike other cellular networks, 5G will likely require, and we'll talk more about this in a moment, literally in your city, we've seen as high as 400 to 500 small cell transmitters per square mile. And so if you're a city like Aspen, Colorado, you're a couple of square miles, you can well imagine that the possibility does exist of having, again, 400 to 500 of these per square mile. And if you're involved in the civil infrastructure or your public works or planning department, be prepared for at least 2 street cuts per small cell tower. Depending on the network and the backbone, you could have as many as 4 cuts. So just in terms of square mile, worst case, if you get 500 of these towers per square mile and you get 2 cuts per square mile, you could be looking at 1,000 street cuts per square mile. A city of Colorado Springs, for example, is over 150 square miles. So take that 150 times 1,000, 150,000 new street cuts in your streets alone. So it may be time to update your street cut repair policies. And we'll talk about that in the future here also. So the next slide here, you'll see really talking more about so what's really happening. Again, worst case is you could have a transmitter going every carrier on every block, as you saw Bart showed there, about 200 active permits right now. The large macro towers are typically at about a 3-mile distance. What's driving the number of small cell towers to really just skyrocket is, frankly, it's the laws of physics. If you're pushing through a lot of ones and zeros, that requires a much higher frequency. They're talking millimeter wave or 30 gigahertz versus 3 gigahertz frequencies to run all those ones and zeros through there. And that really requires that they drop the distance between cell phone towers from about 3 miles on the big macro towers down to about 300 or 400 feet. And again, because they're talking 5G, that really requires a fiber optic feed into each of those transmitters about every 300 feet. And keep in mind, that's a cell tower, it's a small tower, every 300 feet per carrier. And so if you have 4 carriers, you could have 1 tower every 300 feet for each of 4 carriers. That was the point that Bart was making earlier. Really think in terms of why bother. Well, it's some have said it's like the transition from black and white TV to color TV. You know, I really think it's more like going from black and white TV to watching a movie on your cell phone. It's really a dramatic increase in technology. If you're careful, thoughtful, and mindful about the policy side of it, though, there are ways that we think that you can create millions of dollars in new revenue despite these seemingly onerous FCC rules. You can control aesthetics, even though, as Bart said, your agency may not have passed these interim cell phone changes or permanent changes by the 15th of April. You can reduce costs. You can actually piggyback on these, and while they're laying in the fiber optic for their network, I'll show you an example of one we worked on in the Denver metro area, where you can develop your own fiber optic network and arguably create economic development. There's one northern Colorado city that directly credits or blames 4,000 new jobs because of the city government's involvement in creating this broadband, this fiber optic network. And so really it's a tidal wave of attachments, and some would say a tsunami of antennas. One thing I'd like to point out, so if you are a public agency, the questions we like to ask are, do you own pipes in the ground? You probably do. And by the way, they can even be abandoned water pipes. Water pipes that have been abandoned years ago suddenly have value again as fiber optic conduits. We're actually working a project for a small town where we have about 2,000 feet of abandoned water pipe that's now being lit up literally with fiber optic cables. Very valuable if it goes under your main street. Do you control how they're placed? Did you know, by the way, that there's now that the conduits connecting streetlights or conduits connecting your traffic signals may actually be more valuable than the asset at the other end of it. In other words, if you're thoughtful, and this takes a little bit of engineering talent, but it is possible now to co-locate within the same existing conduit, the same pipe underground, fiber optics and electrical conductors. Again, that's not possible in all cases for a variety of reasons, but if you own old or seemingly outdated conduit pipes connecting your street lights, those conduit pipes can be now enormously valuable as conduits for both conductors for the electricity and, as I said, for fiber optic cables. The point here is it's really important to understand these interrelationships between fiber optic, streetlights, traffic signals, broadband, all these things it's complex, they are interrelated. There's revenue opportunities that we'll talk about here in a moment. It's really difficult to gain a grasp of how what I would call the fiber game is really played. And as Bart pointed out, this crazy thing seems to change almost on a daily basis. So just a few words here about streetlights. You know, streetlights are kind of a thing of the past. They've been around for well over 100 years. We'd like to think that that part of what a city or county can do really is taking lighting to the next level. There's a lot of talk now about, for example, dimmable or smart streetlights. Streetlights that can sense people walking up to them, and they can get brighter or dimmer. You can control them for emergency operations. It is possible to co-locate a 5G cellular transmitter within the body of a street light. In fact, there are some manufacturers now coming out with street lights that actually can take two. So you can have Sprint and AT&T, Verizon, and T-Mobile can co-locate two different competing transmitters within a single street light, and that's kind of a breakthrough. That has not existed really until the last few months or so. We're seeing digital signage, we're seeing wayfinding being done. City of Vail, or Town of Vail, up in the Colorado High Country, is even providing now free Wi-Fi from 30 of their city-owned streetlights are Wi-Fi transmitters, so you get free Wi-Fi in the downtown village area of Vail Village. As I mentioned, sensors, counters, and now a lot of these are even dimmable automatically, where they sense an approaching person and brighten or dim based on who's around them. Here's one thing that's really taking parts of the country by storm: Streetlight Municipalization. There are various words for this. In California, it's called community choice aggregation. In Colorado and some places in the Midwest, though, it's really just about a city or county buying out the streetlights that are probably owned by the power company. Some cities, I think in Colorado, there's about 28 city-owned power companies. So this does not apply to you if you already own your streetlights. But if, for example, you're paying, typically what we're seeing is that a typical street light here in Colorado, we just did a study for a suburban Denver city and found that on average they're paying about $20 per street light per month. Interestingly, the amount of power, the value of the electricity that they get for their $20 at 10 cents a kilowatt hour isn't $20 worth of value. You get about $2 worth of power. In other words, you pay the power company $20 and they give you maintenance, possibly, or partial maintenance of your street light for $20, and they give you $2 worth of power. And so cities are saying, hey, enough is enough. We're going to purchase, and the FERC, F-E-R-C, the Federal Energy Regulatory Commission, will allow cities and counties to buy out street light infrastructure out from under the power company. Now, I'll tell you right now, the power companies don't like this. They see the power of these street lights are huge cash cows, and they have every reason to oppose that, but the feds say they got to do it. And so we're seeing a number of cities around the country now. In fact, California's got probably 20 or 30 cities in Southern California that I know of that are doing this streetlight municipalization. Bottom line is, though, that it's well worth doing. We see ROIs of 5 to 10 years. Interestingly, this is not driven by a conversion of high-pressure sodium bulbs to LED bulbs. You know, an LED bulb can reduce your power bill by about 50%. But if you're only paying $2 and you cut that to $1, that's not where the savings is. The savings really is in municipalizing your streetlight network. So the point I want to make here is really that if you don't already own your streetlights, look into that. We can, of course, help you decide whether it makes sense or not. If you own your streetlights in the future, you can control your aesthetics. Obviously, you decide what they look like. One intriguing opportunity, I was talking to a colleague of mine, again, this is an East Denver suburb. He was telling me that if a cell company comes in and wants to locate a cell phone transmitter, small cell tower on a street light, they make them take down the power company owned street light. That saves them $20 a month. That's $240 a year. They have in cost avoidance, and they're charging them, and they're happily paying about $250 a year. So when you look at the cost avoidance of $240, $250 from money that the city's not paying out for the street light that's owned by the power company, and you get another $250 a year in new revenue, that's about $500, $550 a year per street light for each one that they take down, replace, and put up, and becomes a cash cow for the city or county. Literally, this one city has 22,000 streetlights, and we'll talk about again the density here. So there quite literally is, depending on the city, an opportunity to generate millions of dollars in new revenue and, of course, cost avoidance as well. So with that in mind, I'd like to just talk about, this is a city that I've worked in for a number of years. I was Public Works Director in Centennial, which is a South Denver metro city. In blue across is 15 miles east-west. Each of the green or red dots is a traffic signal at the time. We did a little fiber optic co-location project with the state DOT. Here they call it CDOT. Back a few years ago, and this was our first attempt at it. By using co-location strategies, though, by redefining the policies for piggybacking, for dig once and joint build, completely rewrote the book literally, and we went from this was the original fiber optic network, just two little pieces of state highways, to this over about a 4-year period. Phenomenally increased it. Created literally for pennies on the dollar. I think we spent about 600,000 public dollars. By the way, half that was traffic signal dollars that came from the local COG. So for about $300,000 of city money, we created a network here that's been valued at approaching 20 million. So city puts in 300K. The value of the network is about $20 million. And best of all, this next slide shows a picture of a billboard that I took. This is just off of Interstate 25. Showing that now that they've got 60 miles of fiber optic cable in the ground, again, that they created for pennies on the dollar, in comes a brand new, it's not Google Fiber, but it's a competitor to them called Ting, or Ting Fiber, and they are now literally gigafying. They are bringing fiber optic cables into virtually every home in Centennial, again, all starting with this backbone that was put in for pennies on the dollar, and they're monetizing that as well. So they're monetizing streetlights, and now they're being able to monetize this co-located fiber optic or just conduit network. So it's real, it's happened, we've done it, and we're happy to, again, advise anyone who would like some advice on how you can do this too. It's a lot of work, not that hard. But here's a picture, by the way, of kind of the main street in Centennial, looking to the west toward the Rocky Mountains. This is a photo that was developed. It's a Photoshop photo that was developed by the city of Centennial, though, not talking as much about the underground fiber optic network. In fact, this is where the first red line was, but this is what Centennial developed to show the impact of the cell towers. This is not our own rendering. This is a city government rendering showing what a single carrier might look like on their main street and how awful it would be on obstructing the view. So one term that's out there, by the way, is a porcupine with all these pointy things sticking up all over the place. This is a real possibility. The real scary part, though, is pops up here on the next piece of this, where it really talks about the density that's going on here. And so, again, you have to have your policies developed before the permits show up. And even if you don't have permanent ones in place, we've seen a lot of cities in the Midwest, California, here in Colorado, where we're encouraging them, okay, it does take time to get permanent standards in place, we get that, but you can also publish interim standards. And all that takes is publishing it on your website, saying we're working on a permanent standard. That'll take a while to go through ordinances, resolutions, whatever you have through your city council, your town board. But in the meantime, staff members can legally publish interim standards, and you can do that. As long as you got the interim standards posted before the permit drops, you're okay. And that's kind of an important point we'd like to make. What you can do, would you like to own fiber optics under every street? I think the answer there is yes. If you're connecting traffic signals, in fact, the traffic signal that I mentioned where we co-located a traffic signal, hidden one is the upper right corner picture there. Hidden within that vertical mast is a single small cell tower, and we got the company there, Verizon, paid 100% for that replacement at no cost. We got a free mast and mast arm, new traffic signal out of that one, thanks to the carrier. Is there benefit to that? Can you better manage all the aerial and underground infrastructure? And think about your future transmitter sites, reducing your cost, and often going, like I said earlier, from $20 a month down to $2 a month. You can save money on your street lighting bill. You can have your cake and eat it too, and create a fiber optic broadband network that you can use and you can flip and monetize to the private sector. Interestingly, we'll talk here on the next slide about a related topic, which is a word that's being used is called densification. That's a difficult word. This is for a client in the North Denver area that we did, and each of these little stick pins is a conceptual layout showing what all 4 carriers would probably come in with in a typical, this is a, and we deliberately picked this as a blended neighborhood. It's got some apartment buildings, as they're called in the industry, MDUs, multiple dwelling units. So to serve the MDUs, all 4 carriers would definitely be there because the density is there. They probably would want to serve some of the residential areas around there with 5G, and then there's also some commercial and some warehouse space. So this is kind of a blended area, but at this density, here's the scary part about this. This next bumper sticker will kind of, that if you remember nothing else in this presentation, I'd suggest try to remember, unbelievable as it is, we've seen estimates approaching 500 towers per square mile. And again, as I said earlier, if you assume 2 street cuts per tower, that's 1,000 street cuts per square mile of town. And here's the really scary part. Depending on the density of street lighting you have in your town, one city that we're working with has, they're a small city. They've got about 790 streetlights in this one particular West Coast city, and they've got 10 square miles. So they've got about 80 lights, 80 streetlights per square mile. Cities in the Denver area that are unlit, we've seen as low as 50 streetlights per square mile. We've seen over 100 streetlights per square mile. But the point I want to make here, this is a foot stomper, is that that the density of the cell phone towers, these multi-cell towers, can be 4 or 5 times the number of streetlights that you have. So think of every streetlight. If you do nothing, you'll have a streetlight sticking up, and the possibility of 4 or 5 times that number of small cell towers located, as Bart said earlier, pretty much anywhere they want to go. And the bottom line is you can't say no. That's the creepy part about this thing. So a couple things you can do. We'd like to talk about not only the aerial equipment that you can get your arms around, you can publish interim standards to get your arms around and control what's going on above the ground. But I think equally important here is now is the time probably to look at what kind of ground equipment regulations do you have. This is a lightly permitted one, which means not really much permitting at all going on. But again, you can't say no if you don't have the public policies in place. And so the point here is that that we'd like to strongly encourage, in addition to what's going on above the ground on the aerial side, is that the cities also must act before the permits with your on-the-ground stuff. And lastly, the third and next slide here will show not only what's going on above the ground, on the ground, but now is also the time with a huge number of street cut permits coming your way, whether you like it or not, and you can't say no. This really is the time now to update your street cut policy. I can tell you that in Colorado Springs, I worked on not too long ago a policy that generated more than $1 million a year through pavement degradation. They call pavement deg fees, which is advance payment for the street damage before it actually occurs through pavement degradation, and also then doing full cost recovery, or striving to get full cost recovery. So you are not subsidizing the cost causers, as we say, but you need to act again before the permit hits on both above and below and on the ground. So there's a lot of work, a lot of updating that we really strongly encourage your folks to do regarding these permits. And I think my time is just about winding up here, so I will turn it over to George Wentz, who's based out of the West Coast, to be our closer and do some foot stomping and really illustrate some of the important takeaways we'd like to suggest you all leave this webinar with. So George, sir, over to you.
Appreciate it, David. I just want to take a few minutes to go through just about 4 slides to hopefully we're encouraging you to generate your own action plan of how you are going to address the legal as well as technical questions. And we really want to just get you thinking about that impact that small cell technology has on your local government. So you can expect there's going to be some types of resistance out there. Matter of fact, we've heard, again, matters brought up related to any health impact by the new technology that's out. We're now hearing some of that input from communities. So we're really encouraging all of our entities to make sure that their elected officials are familiar with what is transpiring and how it impacts the city, and that you work hard to strengthen your own policies, whether they're interim to get you through a short period of time, or whether you're already in good stead and have procedures in place. Go back and review them just to make sure that whatever actions you plan for the future, you do have a strategic plan in place on how you're going to address this whole telecommunication area in your particular community. So we are suggesting that you take a look at your public policies and how they impact your community in the future. So right now, the kinds of things you can do is take a look at your particular fiber policies and how are they friendly to the community out there while still understanding the impact it has on your city and the different areas you can address. Davis talked about co-location, municipalization of your programs as well as your street cuts. And so we're encouraging you that you make this whole small cell regulation that you've been hearing about a #1 priority as you look at how to address these particular technologies. And as you've heard, Chris, that the new rules do impact our I guess strategies and what we need to do, whether it's above ground or whether it's on the ground or whether it's below the ground. There are some potentials to address your revenues that are needed within the community to address these cost impacts upon your areas. The next area, again, was the technical aspects, and you've heard again about the municipalization of streetlights, but again, we're encouraging you to also have the backup that you need to, I guess, support any particular decisions that you make within your local community and how you're going to then move forward with your technology to try to the best of your ability to update your systems and to meet the requirements of the new technology for your community. So our suggested next steps to you are that you do have a champion internally of basically managing your entire technology as it relates to small cell, that you work hard to understand how your systems address that particular arena and what you're going to do strategically to meet the needs of your community and how you're going to establish processes to meet your strategic plan. Again, a plan of action for your council so that they can help develop that master plan within your community and to define what that looks like and to optimize your leverage and to seek help where you need it, and again, not to delay. So with that, Chris, I'm going to turn it back to you and let you kind of conclude our comments and processes here.
All right, thank you very much, guys. I do have some questions I'm going to ask, but before we do, I just want to let everybody know that we have another webinar scheduled on May 7th that is going to talk about more advanced tactics, such as what you can do to get ahead of the small cell wave. You'll learn about collaborating with telecommunication providers and stakeholder agencies to revisit permitting programs and practices. We'll talk about some applied case studies from communities like yours and what they've done to combat the increased load for permits, plan reviews, street cuts, and inspections, and learn about creating innovative ways to solve these challenges. So after this webinar, you will get an email with a recording of today's presentation and a link to this advanced session if you'd like to join. You're more than welcome. So now we'll get into some questions I have from the audience. The first one is from John Joyner, and the question is, what is the typical cost for a smart street light?
Chris, I'll take that. This is Dave Z again. I'll take that. A smart street light, interestingly, is not that much more expensive. In contrast, nobody calls them dumb street lights, but a standard street light really depends a lot on if it's a new subdivision you're putting it in when the road's all dug up versus a smart street light. A good rule of thumb can be if you're retrofitting it and you're doing boring between the street lights. We were seeing typically, in fact, a boring cost per linear foot because a smart street light doesn't have to have fiber optic cables, but it's highly desirable that you put it in there. And so per linear foot, if you have to bore in fiber optic conduit, 20 to 30 bucks per linear foot to get the fiber in is what we're seeing. One of our clients on the West Coast said they saw micro trenching going in, which is a groove in the pavement, at amazingly, they said $66 per linear foot to interconnect these transmitters with micro trenching, which is normally thought to be less expensive than boring, but really depends on the distance between streetlights. The streetlight itself, what we're seeing is about, and it really depends on what services, what sensors you want to hang on them. But what we advise is that just for starters, if you're putting in a new streetlight or you're doing a retrofit because you're converting to LED, absolutely, if you remember nothing else, make sure that you put in a 5-pin or 7-pin socket on top of the luminaire. That's crucial because once you've done that, then everything else kind of flows through. If you only put in a 3-pin socket on the top of the luminaire, then you're kind of stuck. You've got to replace the luminaire in the future. So if you're looking for a phased way of doing that, start off by converting it to LED. If you want to, put a 5-pin socket in there, and then you can hang on there any number of different things you want. The straight answer to the cost, though, is figure about double, about $1,000 for a standard street light if you use an auger to drop it in, and maybe $2,000 typically for a street light. Again, depends on what kind of a network, what kind of fancy things. I've seen as high, actually, some of them have gone into the $6,000 and $8,000 per street light range, but that's one with bells and whistles, and one that has both, they call it belt and suspenders. You got fiber and you've got a telecommunications network that goes wirelessly connecting all these things. But typically about twice the price. But if you just upgrade right now to the 5-pin socket, you pay $10 more to do it, and do it in a phased fashion. So anywhere from $10 to $8,000. How's that? It depends.
Thanks, Dave. I have another question here. It's how can we make sure we can allow for proper aesthetic review and requirements? Dave, that might be another one for you, I think.
Yeah, I was thinking maybe, or Bart, you want to talk about aesthetic requirements? It could be kind of a legal hook there.
Well, yeah, thanks, Dave. This is Bart again. Yes, the most important thing to do is to get aesthetic requirements in place as soon as you can, because there is an argument that if you don't have them in place, you're not going to be able to enforce them. You know, so that's the main legal issue. In terms of technicalities, I know Dave and George, you have actually worked with the specific kinds of requirements that that local governments require for these types of facilities. So maybe you guys can comment on that.
Yeah, you know, I would say one project that we're actually just wrapping up now for North Denver City, and we've had, I think, 4 in Iowa that we're also just wrapping up now. What we tend to strongly advise our city and county government clients to do is to establish a minimum aesthetic standard. In other words, in your policies, you can say, and we've actually included examples of specific light standards, street lights that do meet the city's aesthetic standards. So, for example, here's a small list. Here's some pictures of ones that do meet our standards, and you can pick any one of these. If you're T-Mobile, you're Verizon, you're coming in, you can pick any one off this list, but you can't go beyond this and put a Franken-pole up, for example. And so one way that we handle that is to really specify these are the approved ones, or you can have a waiver granted upon request. I can tell you right now that the big pushback you should expect to get is, and we recommended this in a number of cities, is that we strongly recommend that you try to require the providers to put 2 companies in one pole. So, for example, and they hate doing that. T-Mobile hates to be helpful to their competitors. I get that. To Verizon hates the other guys, but you can require, and we do advise that you require, when possible, to make room in the new street light, the new small cell combo street light, enough space internally to accommodate 2 transmitters, because you don't want the 480 transmitters per square mile. You can, right now the technology allows you to put 2 within one street light pole, and to the extent you can do that, require that now. So those are the kind of things that you can do now. Hope I've answered your question there.
Chris, this is George. Let me quickly chime in too that believe it or not, there has been willingness on part of these different providers to meet and to discuss and to negotiate just what they can and can't do, or what they're willing or not willing to do. But I think if agencies do talk to their providers early on and try to work on a common solution, we're finding that cooperation and willingness to do so with the different providers is still possible. So I would encourage everyone to reach out to their various providers and see what can be discussed as part of this entire process.
All right, thanks, guys. I have 3 more questions that came in. The next one is, what level of specificity in small cell regulation does the FCC allow municipalities to have? Can municipalities use specific use permits in which conditions may be added on a case-by-case basis to regulate small cells?
Do you want me to start out on that one from the legal perspective?
Sure.
Yeah.
Okay, this is Bart again. The FCC rules are not entirely specific on that point. However, I think you can use whatever form of regulation your community is accustomed to using. And in terms of applying various conditions, the thing to be careful about is to not overreach, because of the potential preemption that you can get if you get a lot of pushback from a provider. So that's really the caution there, you know. But I think you can probably you definitely can use whatever type of regulatory vehicle you have been using for these types of approvals, you know, in the past.
Good point, Bart. This again, one thing that I'll tag on, and maybe just to talk about there, is a strategy that we also encourage our counties and cities to think about, is what's called in the industry plug and play. You know, the bottom line is that these providers really don't want to fight for each cell phone tower. One West Coast city that we're working with now is talking about between $2,000 and $3,000 per streetlight and a public process, a public meeting for every small tower that goes up, and we're talking dozens of these at $2,000 to $3,000 per. I tell you right now, the providers don't want a big fight with the cities, but what we do advise our cities to do is to do the plug and play option. In other words, if you know that you are replacing streetlights or you have traffic signals, the city of Aurora, Colorado, for example, requires or actually encourages co-location of small cells on their traffic signals. CDOT, the state DOT here, prohibits small cells on the CDOT traffic signals. But what I can tell you that we'd like to encourage our clients to do is, whenever possible, to make it easy for the inevitable, and make it easy for the providers. You know they're coming in. If you're a small ski town and you've got a downtown area that you know is going to be pounded with each provider once high densification of their cell towers, you can take steps now to, for example, you're replacing a traffic signal, put all 4 quadrants in, allowing for a provider to go into each new mast that you're putting in. Put the power in now, put the fiber optic cable in now, so that all the cell tower company has to do is plug and play. They come in, wow, you've made it very easy for me, there's no fight, and by the way, you can charge them for the service or for the ability to use the plug and play feature, that they don't have to install their own equipment. So that really is kind of a proactive approach, which avoids the fight, versus a reactive approach where you're arguing over $3,000 per pole in a public meeting over each cell site. They don't want that. You probably don't want that after all. But there are little tricks that you can do to make it easy for them and be proactive.
All right, thanks, guys. I have a question here from Charles. He said there was a recent court decision regarding a challenge from the city county of San Francisco. Can you provide an update on this case and how it impacts the ability of cities to enforce aesthetic impacts?
Yes, I can take a shot at that. This is Bart again. Yes, the California Supreme Court, I think a couple of weeks ago, decided a case where they held that a state law that seemed to preempt local authority over small cell siting and requirements and so forth did not in fact preempt local home rule authority by cities in California over those kinds of local land use actions. So, essentially the update is that the cities in California, at least with respect to or vis-a-vis state law in California, have been given a leg up in terms of regulating small cell placement and siting.
Thanks, Bart. I have one final question here from Janet. She says, how do us planning types get the public works folks engaged in this issue?
The easiest way, maybe George, you can talk about that too, but having been a public works director more times than I care to count, and I can tell you that you tend to get their attention when you start cutting their streets up. One guy that I could have choked years ago was the head of a local gas company, said, Dave, the reason that we like to come in and cut your streets right after you pave your streets is, quote, because warm asphalt is easier to cut. Ha, ha, ha. Well, that's a sore subject, but when it comes to thousands of street cuts per square mile or 0 street cuts per square mile, if you do it proactively, that's probably a good way to start. You can also look at these revenue generating things. If it's the Public Works Department that either pays now for the street lighting bill, you can get their attention with that. You can also look at replacing those traffic signal poles for free with the incumbent providers out there. And I can also tell you that upgrading the traffic signal interconnect, in other words, I hate to use the word synchronizing traffic signals, but coordinating traffic signals on major corridors, you can get a double whammy there. You can interconnect your traffic signals, and the same fiber you can flip and lease or sell the excess capacity, as it's called, to these providers. So you can generate money through a variety of ways: the conduit, the fiber, the traffic signals, avoiding costs on street lighting, and then avoiding these street cuts. There's a lot of ways you can encourage your public works people to say, hey, there's money, it's to your benefit, please work with us to reduce your own damage to your own infrastructure. So George, I know you've been public works director more times than I have. Thoughts about that also?
Well, no, I agree with you, what you said, David, very much, that I think from an administration point of view as well, if that can be documented, generally the leadership too within the city will help support the department's goals on moving forward with that technology and basically getting the support and backing that's needed within public works or engineering to complete that effort as well.
All right. Well, thank you, guys. I'd like to thank you all for joining us today. And again, thank you, Bart Miller, George Wentz, and Dave Zelnok for the great presentation and discussion. And thanks to the audience for your interaction and your questions today. Like I said, you will be getting a follow-up email with a recording to today's webinar. If you have any questions, you can just reply to that, and I'll make sure that someone follows up with you. Also, look for a link for our next webinar about more advanced tactics. And thank you, everyone, and have a wonderful day.